Hello and welcome everybody to a new video. So, you've seen the title of this video, you know what we're talking about. This is an Advent of Code video. It's also a Rust video. But the first part, Advent of Code video, you might be asking yourself what's going on, Ian. It's not December. What are you talking about Advent of Code for? And indeed, you'd be correct, it isn't December. So if you've followed my channel for a while, you'll know that I am obsessed with Advent of Code. I absolutely love it. I've done it most years over the years since I think, well, so we can see, since back to 2018 was actually the first one I did. These are giving you a hint as to what I've been doing more recently. I've gone back and started from the very start to work through them all. But yeah, I've been doing this since back in 2018. I did some in 19 and 20, not very much, and then I got quite seriously into it from about 2021 onwards, and for the last 4 years I've done most of it with reasonable levels of success. I've never gotten all 50 stars. 47 is still the best I've ever done. So in both 2014 and 2015, I managed to get 2 stars on everything except for one day. And then that has obviously meant that I didn't get the final star, which leaves me with 47 in total. So that's my record. But yeah, fair to say, I absolutely love this thing. There's something about it I really enjoy. I don't know exactly what it is. It's the silliness, it's the complexity of it, the problem-solving nature, all these things combined, just using code to solve fun problems that I absolutely love. And yeah, it really just ticks scratches a little itch in my mind, which is something that I love doing. So anyway, what am I doing? Why did I go all the way back as of January? I started doing this. Why did I go back to 2015 and start working my way up the way, which is what I've been doing. So again, if you've followed my channel for a while, you'll also know that I more recently have become kind of obsessed with Rust, the programming language, and I'm trying to, on a bit of a mission, to just put Rust everywhere and just see what I can do with it and see where I can use it. So if you followed a few of my other videos, you know I have some videos on programming STM32 microcontrollers with Rust, which I really enjoying doing. That's kind of become my go-to for my embedded programming. And one thing that I had said to myself was that I didn't think Rust would be particularly good for this type of algorithmic problem solving where I'm needing to debug data and go through stuff, and so that's why I thought to myself, well, for using for Advent of Code, I don't think Rust is going to be a great language. But the community around Advent of Code has seemed to take the opposite opinion on this, and I've noticed more and more in the solutions threads over the last 2 years, tons of solutions in Rust. A bunch of people who I know personally who do this as well have all started doing this in Rust, and so I said, well, I'm using Rust for everything else, why not try and use it for this? Before this, I always used Ruby for Advent of Code, and there was a couple of things that I really liked about using Ruby. One thing is I'm very fast writing Ruby code. Ruby code itself is very naturally fast to write, very syntax light, and it has a really good integrated debugging environment called Pry. So if you have used Pry for debugging, you'll know exactly what I'm talking about. It makes your debugging feel almost like a superpower if you're able to use Pry. So you can interactively debug into your code really naturally, really easily. That's just a really nice thing to do. So because of my reliance on that, and my reliance on just speedy, quick, type it out, hack it together, and see if I can get what I want out of it, I never thought that I would be able to use Rust for Advent of Code. Seems I've proven myself wrong. I've done almost all of 2015, bar this one. There's one puzzle, day 19 in 2015, which doesn't seem to be all that complicated a problem. I just couldn't seem to solve it, so I decided instead of banging my head against it, I'd just move on. My plan is probably to just keep going through these, for fun, do one every couple of days, and if I get stuck on one, I'm just going to skip it. I'm just going to move on to the next thing. If I get stuck on a part 2 of a problem, I'm just going to move to the next one. I don't care. I'll come back. Maybe I'll sweep back through them eventually at some point in the future as I've gone through them all. I don't plan to get all these done this year, so I will definitely come up to this year to 2025 solutions, and I'll just leapfrog to there and start writing them in Rust as well. Hopefully my Rust foo will be pretty good by that stage, and maybe I'll be able to crack out one a day. We'll see. that's up for debate, but we'll see. And yeah, I don't know how far I'll get up through the years, but anyway, that's what we're doing. That's why I'm doing this. But what I want to talk about today is the application that I've written, which is my sort of CLI runner harness thing for wrapping up all my solutions and being able to run them with terminal commands, which is very similar to basically the exact same thing that I used to have in Ruby. I've kind of just ported it over to Rust and had to bend my brain to making it work. And I'm going to show it to you guys here. It's really simple. Some of it's not architected very well. There is some kind of cool stuff in here that I started learning about using procedural macros, which is very cool, a little bit brain breaky, but I got some cool results with it. Again, there's probably way easier ways to do all this stuff, but this is just how I've kind of muddled my way through it. I'm learning as I go with Rust especially, and just kind of having fun doing it. So with all that said, let's start looking at some code, and yeah, let's start talking about what we have here. This is gonna be a bit rambly, a little bit, unstructured, but I hope you guys enjoy it. And yeah, but just bringing you along with the journey with me. And yeah, let's see what I managed to get. So first place, I'm gonna go to my GitHub. So you can find this at github.com/carey3 is my handle on GitHub. AOC, Advent of Code. It's a public repository, so you guys can have a look at all of my code and all of the structure for this. They're all free to use. So you'll be greeted by the README. Very simple, just some basic instructions on how to build and run it. There's some query params that you pass into my application that figures out what year and day of the solution it wants to run, and then where your input is and everything for it, and runs it. The one thing that's worth calling out, so the code should all just work as it's written with the commands. The only thing you have to provide is you'll have to provide your own inputs. So I kind of call out down here in the README that because of intellectual property, I guess, and also I think the creators want that this doesn't just get spoiled by people being able to crack the generators that he uses for stuff. He requests that you do not publish the inputs or the answers for any of the days. So I've abided by that. I have my inputs in my local in an input directory, which is not shared in Git. So these are all my individual inputs in here. And yeah, they're not shared in here. So you'll have to create your own. It's quite a simple structure. It's just a folder called inputs, and then a folder for each year, and a folder for each day. Within each day, there's 2 files. Usually I use 2 files, input and sample, but you can have as many files in here as you want. And then the last parameter of the arguments for the CLI is basically the file name as it's written, and then that is it really. So cool. Okay, that's basically it about the README. Let's talk about how it actually works. So what it does. So I said there's a few input arguments here into the app. So CLI accepts first parameter is the year, then it takes the day, then it asks for the part, and it asks for that input file, which I already talked about. So they're all pretty self-explanatory, the first two anyway, year and day. If we go through my solutions, you'll see I have a folder for the year. I have then one file for each day. And then if I click into each file, you'll see that I also have a part 1 and a part 2. As is tradition for the Advent of Code, there's always 2 parts, part 1 and 2. And yeah, that will map to your first 3 arguments. So the year, the day, and then the part, and that will either be part 1 or part 2. And then the input is usually, so I think I thought that because I had only started it around about 2018, I assumed this was always the case, that he always gave you your input file, and then also there was usually a sample, which was the exact same data, but just in text format in the problem description. Turns out that's not always been the case. He actually, in some cases, the input is like a text string that's just in the description that's generated for you. And in some cases, he also doesn't give you any sample data at all. He just describes the problem, and then you have to go off and do it. So that's why I had this by default, sort of this pattern of input sample. But it's the same. You could just copy paste it in. Doesn't really matter. The basic part, all it does is my first part, I have this kind of boilerplated into my code where I basically just have a a helper function which just reads the entire file line by line, and then you can just do what you want with it after the fact. So it's not necessarily the most efficient because of that, but it's a simple way that my brain works to do this. And it's also a pattern that I used to use in all my Ruby code. I used to usually start by just reading the whole file in line by line and doing stuff with it then. So that is why that is why it is the way it is now anyway. And yeah, that comes from, for me, this file reader just comes from these utils, file reader. Now that's it, just reads the lines. There's also in one of these solutions, you see I have this solve thing. So I won't go too much into this, but basically this is just how I've managed to do my layers of abstraction so that I can make everything structured in a way that it's all the same types going around. It just figures out what it does. I'll get into it. You'll see it in a minute. Right. So I guess where I should start maybe is just how it runs it. You start from the very start, go to the very outside directory here, and we've got in our src, we have a main, and this is just the entry point for the whole thing. So this takes our arguments that are parsed in. There's a parse function in here. It's ugly, but it does the job. This pulls out all those arguments. I've been meaning to maybe move this over to a crate. There are some nice CLI crates that you can use that will handle argument parsing and help documentation and stuff. This just does some real nasty, dumb stuff, but it works. It's fine. I don't really care too much. Basically what it does, you'll see as I go through this, there's sort of these layers of abstraction where I use this pattern here where I use hash maps all over the place. The hash maps have their keys, which represent different things. So in this fetch func, it basically is a hash map which has an integer, which represents the year, and that matches to a runner function, which in this case is called like run day from each of these years, which I have kind of casted as just an anonymous function here that takes in these parameters and returns you a parameter of string. That string parameter that's being returned here is the answer, and that is what will get written out to the terminal when you enter and run. The answer, the solution, whatever it is, will get written to your terminal, and it'll just get formatted as a string and get spat out. And then at the very end here, that gets formatted here. Answer, done. So if we go into one of these then to figure out what this actually is. So this comes from a module named Y2015, which is here, which is defined here as an external crate. So if I go down here to the lib, we have where that is defined. So this goes, and this is an implementation for run day for 2015, which comes from my harness utils. So if I go into my utils, I can go to my harness, and this is all that this does. So there's a trait for run day, and run day has two functions within it. It has fetch days, which is just a hash. Again, you see another hash map. In this case, it is a string, and then that maps to a function and returns a string. You can, I think you might be getting where this is going. It's like turtles the whole way down, really. It's just hash maps. And then there's also this another function in here, which is run days. And run days is just a function that lets you execute the solution for a specific day. Okay. The more as I talk through this, I believe this is becoming more and more unhinged. This is all just how it occurred to me to lay this stuff out. And as I talk through it now and without re-interrogating this is terrible. But it kind of just is what it is. It works. So, I'm not too grumpy about it. But you'll see we have this other trait called solve. So this is what each of our days actually implement. So if I go to any one of my days here, you'll see that this is the implementation for solve for D02, and that is the struct that I have defined up here, which is day 2 of 2015. This is the solve implementation. You have a part 1 and a part 2, and then this is where your actual code goes that does whatever it has to do, and then returns a string as the answer, which in this case is some that I've determined in here. So that will get returned inside. So sorry, let me go back to my harness again. Yeah, so in the harness, this is all getting processed here. This all so it goes through, it can call solve, it matches on the part, which is in the input here, whether it's part 1 or part 2, and then that knows that it needs to execute the self part 1, self part 2, which calls those functions that are defined in the module. Excuse me. It also does some rough time stuff in here, so it does a timer using instant roughly records how long this thing took to run, and then it'll spit it out here as a duration, a runtime thing, which you can then read off in the terminal alongside the answer. So what else am I missing? Oh yeah, so what you noticed maybe back here in my main function, because I'm using a hash map, I basically have to statically define that here inside a function. So Rust isn't super flexible in terms of how you can define data like this, or at least I haven't found it to be. So in things like Ruby, which I'd used in the past, you can sort of define arbitrary hashes of constant values and stuff, and it's fine. Ruby just handles it. Because obviously interpreted language can do all this sort of stuff without you having to think too much about it. This is a little bit different. Rust obviously is a bit more restrictive about how you can define stuff and scopes and memory, but also it's a fully compiled language, so it needs to be able to compile what this is doing. So basically you're kind of stuck with defining, something like this, which isn't necessarily super nice. For the years, it's not too bad. So I have to manually copy and paste one of these in for every year that I create. There's not that many years, so it doesn't have to happen that often. But what there are a lot of is there are a lot of days. So I was at first just literally, I have a template which is in this like scaffold script. I was literally like copy pasting this into a file every day, and then going into this lib directory, and inside here I had another hard-coded hash map that I was typing in, and it was a little bit of a pain to do it every day. So I was on a mission to try and automate this as much as possible. So what I wanted to do was just create a file in here and just poof, have it all magically included. And that turned out not to be that easy. So I had to do a couple of different things. First thing I did, which you'll see up here, is I had to use the automod crate. So if you've used much Rust, you'll know that you have to manually define modules, basically, which for something like this, where I've got 25 modules in here, it would literally look something like mod 1, mod 2, and it would literally just be that over and over again the whole way down. Which isn't particularly nice and clean. So I didn't want to do that. It also meant that I couldn't just throw a file in here and have it work. I'd have to go in here and update the code, and that would be a bit of a pain. So to automate it, that would be even more of a pain. So I found this automod crate. Now what it does is it is a procedural macro which looks at a directory that you supply it. So in this case, it's going to look at the solutions directory, and it effectively unfolds to all of those mod statements in one after the other when it goes to compile it, which is quite nice. So you don't have to type it in yourself. So I guess this is the part where I'm going to start talking about the procedural macros that I wrote to make this, because obviously this is just a crate that I'm using. But this gets a bit complicated. Procedural macros are kind of difficult. Macros are something that I've known Rust had for a long time, but I've kind of just used them but stayed away from understanding them because they're a little bit difficult. Basically, macros are just Rust-like code that writes other code, so it's just generators. So if you have been programming for a while, or you may know the idea of like dynamic programming, and you may understand the ideas of like other programming languages have of something like reflection, where it's very much to do with the runtime. And try not to talk too deep about this. Also try not to say too many things that are wrong about this, but in interpreted languages, for example, you can write something like in Ruby, you have the eval statement, so you can give it a string and say eval this string, and it will execute that string as if it's code, which can be really useful for things like this, where you're like, you don't know what you're actually looking for, you just want to pass in a thing that you think should work, and then it'll just do it, or it'll hard fail, one or the other. Rust doesn't allow for anything like that. It's a completely different programming model. In fact, any fully hard compiled programming language won't let you do that. Even the term reflection, which I use from my time writing .NET code, is a bit different again, because .NET again isn't fully compiled in the same way that this is. Not natively compiled, it compiles to its own runtime. So yeah, there's kind of different ways of thinking about this, but basically to achieve sort of some dynamic stuff where I don't want to write all this code, I'm not sure exactly what it's going to look like, but I need the code to be a certain way when I compile it, you have macros in Rust to do that. And so that's what our macros do. So I'm not going to get too deep into the weeds of exactly how this works, but there's two folders in here, one called macros and one called proc macros. Proc macros is defined as an external crate, which is something you have to do because specifically in Rust you have to, or in Cargo, I guess, you have to define so any crate that exports a proc macro or procedural macro has to be defined as this proc macro is true, and all it can do is export procedural macros. So you can't embed these alongside your regular code, you have to have it as its own crate. Not exactly sure why that is the case. Someone else maybe in the comments can leave. Don't exactly know why. I'm still learning all this myself. But in any case, we have macros, which defines some basic traits. Then we have proc macros, which defines what the actual procedural macros themselves are. And then in our code, so I'll go down to this, you'll see we import the macro itself from our macros folder, or what the trait is, and then we say that we import the procedural macro, and then we define that it is going to be so this is specifically a derived procedural macro. Like, don't worry about it. Don't worry about it. Called get days. It's defined on this struct, and then we can call that through here. So if we go to the definition of this, it'll tell us it's here. And if we go into this, it dumps us here to this procedural macro definition. And then we can follow this code path through to see what it actually does. And this is pretty messy and pretty janky. I also copied a good bit of this. Got to put my hands up. I copied some of this from this guy itself, the automod crate, because this exports a procedural macro, so I was able to use this to do some things, but it took a lot of scratching my head and and pulling what little hair I have out to figure out what was going on with inside this. The basic thing, what I can tell you what it does is it goes through the solutions directory where you have it defined, which it's hard coded here because I know it's always going to be this solutions directory that I care about. You probably should make that an input so that you can change the directory. Anyway, it won't work if you move that directory around. What it does is it then tries to generate this implementation, which is a trait implementation of this get days, which is the macro that we defined here, get days. So it implements that, and what it does is it builds the hash map of string, which is 01, 02, 03, and then 24, 25. It builds that string with the function that it's going to execute, and it does it using a couple of different crates. So it uses the proc macros 2 crate, which is, I'm not gonna talk about too much about what this is, but basically this lets you work with this library quote, and what quote lets you do is quote is basically a DSL domain specific language thing that they've built that allows you to write symbols that look like Rust and translate it to a string, and then from a string tokenize it into this token stream thing, which is what the proc macro expects to return. And then what this does when it compiles, this basically is what unravels to give you the code. I can't explain it any better because I don't understand it much better myself. But that's kind of what it does basically. So if you scroll down through this, you'll see there's tons of indirection in here. There's this weird syntax with these hash symbols. This is part of the quote library. So the hash symbols are what it will expand out variables that you've defined, and it will then basically splat them into this blob string thing, which will then get turned into the token stream that you want. That's sort of it. Anything else in here? Yeah, I'm not going to talk too much about it. You'll see I have to do loads of funky stuff down here with like string names and stuff, and then like different identifier definitions, which all go in here, and then you make up all these strings, and then you sort of compose all these chunks together into what looks like actual Rust code, and then that is what will get injected by the compiler when it compiles. And one nice thing about this, because of the way all the tooling is set up, is that like none of this looks very obvious what it actually does, but when it compiles, it's static. What it compiles to, it basically spits out this static thing, so that when Rust Analyzer, which is running in VS Code here, when it goes and parses this file, which depends on this stuff, especially also this automod stuff, it applies the same way. It's already compiled that stuff, so it knows what it can do, and it knows how to bring you how to navigate around the code as defined, and it'll all work, and it won't show you up any like red squiggly lines under it once it's been built. So that's all pretty cool. And yeah, that's about it really. That's kind of all I want to talk about. It's a bit rambly. I can show you maybe some of it running. So if I go script run, and then I go like so let's say 10:16, I'm gonna go day 1, part 1, running on the input, and then hit enter. Oh, well that's bad. Oh, I must have copied it. Damn it, I've done something. Oh no, what have I done? I was copy pasting somewhere. What is that? Where's that thing? Oh yeah, I pushed this thing without having. No, it's back up to that here. What is this? F974. There we go. Silly me. There we go. Yeah, compiler warnings for some other code that exists there, but that's fine. You see it spits out the runtime here at the bottom, and spits out my answer to whatever that problem was, whatever my solution thing was. So it does work. You can also debug into this stuff. So if I go into, because I've set up in VS Code, I have set up this launch config. Very simple. Just give it the build commands, point it at the right directories and stuff. And then also have this simple input command thing set up. So then if I hit F5 on my keyboard, it builds. It gives me a prompt with what to run. So if I hit enter, that'll just run. You see I get my answer spit out here. And then if I go to this, go to the code itself and say, just put a breakpoint arbitrarily, just kind of anywhere. And then same, hit F5, hit enter. It dumps me straight to that breakpoint, and I can debug through this. So setting up this was actually another thing that I wanted to do to be able to debug this well. So usually when I was using Ruby, I just used the terminal with pry to debug in the terminal. But can use, like I could use LLDB to debug in the terminal with Rust, but it's just not as nice as pry. So the interactive debugger in VS Code is a little bit nicer. It gives me all this, the variable definitions up here, and it's a little bit easier to work with and setting breakpoints and stuff. And it works really well. I'm very happy with it. I can skip, I can jump. There's nothing weird in here with threads or with anything like that. So it's just straight up, run straight through, and able to debug it really easily, which is very nice. So there we have it. That is what is that? That is 30 minutes of rambling about this. I commend you if you managed to make it this far. you should be very proud of yourself, because this is a lot of nonsense that I just talked for the last 30 minutes. And thank you if you managed to stay listening this far. So I think I'm going to leave this here. I don't have anything else to say. I'm going to keep working on this. I'm going to keep doing days of Advent of Code because I just enjoy doing it. And I'll keep publishing them. I'll keep refining my Rust skills and keep refining how things work inside this, and I'll make it better. It'll get better over time, and yeah, that's about it really. So thank you again for watching. If you made it this far, big props to you. If you enjoy this content and you've and you get something from this, you can support me on Patreon, and you can also support me with channel memberships. Links all down in the description. And aside from that, just thanks for hanging out, thanks for listening, and I'll see you guys in the next one. Bye bye.